All right, continuing where we left off. Okay, so we'll be doing question number 9. So pretty simple, with a rational denominator, which means we have to remove the roots. All right, simple as that. So when you look here, you can see that it is plus here, right? So if you're rationalizing, the sign will change to minus and minus here. All right, simple as that. Next step will simply be just multiplying. So 21 into 3, we're going to get 63. So we'll have 63 root 5, and then once again 21 into of course the sign is minus, okay, because you can already see a minus is there. So when I multiply 21 into root 3, it will simply be 21 root 3. Okay, so remember, outside, inside can multiply. All right, now if you look at the denominator, it is of the form what? A plus b, a minus b. So which is of the formula for this, a square minus b square. Okay, so you can already see I've written here a square minus b square. So once we're done with it, let us open the bracket. So this square is for both root 5 and 3, right? So which means 3 3s are, we're going to get 9. Then root 5 into root 5, it will simply be 5. And then once we're done with that, the square and the root will get cancelled, and we'll have here minus 3. All right, so if we're done with that, 9 5s are 45. Then 45 minus 3, we're going to get 42, right? Now if you look here, can you see that this 63 and 21 can be multiplied by 7. 7 9 is 63, then 7 3s are 21, right? So which means I can take out 7. Come on, so that's what I've done here. 7 9 is 63, then 7 3s are 21. All right, once we're done with that, then I can divide these two. 7 1 is 7, 7 6 are 42. It should be 6 here. All right, so once you're done with that, again if you look, can you see this 9 and 3, which means I can take out 3 common again, right? So you can already see I've taken out 3 common. 3 3s are 9, and then this 3 already taken out, so nothing will be left there. Okay, and we already know that 6 is below here, right? So 3 1s are 3 2s are 6. Okay, and then our final answer is going to be what? Root over 3 3 root over 5 minus root over 3 divided by 2. All right, next, simplify. Once again, by rationalizing the denominator, we have to remove the root. Okay, now all the other equation, they were just 2, but now can you see that we have 3 root over 6, then root over 5, then root over 11. Okay, so here we'll combine these two to be 1 and these to be the other. So in a way, trying to have just two of them. Okay, that's why it is under bracket here. Clear? So now if this is minus, this will be plus and plus, right? So if you look at the first numerator, simply 1. So even if I multiply 1 into root 6, then 1 into root 5, then 1 into root 11. So not, I mean, it's just simply multiplied by 1, right? So nothing is going to change. If you look at the denominator, a minus b, a plus b. So remember, okay, these two are a. All right, so it is of the formula again, what? A square minus b square. So you can see here I've written here a square minus b square. If you're done with it, again if you look here, this is again a plus b the whole square, which is of this formula again, right? So I can write a square plus b square plus 2 times ab. Right, so this is expansion here, a square plus b square plus twice a b. All right, so look at a square now. So I can divide this square and the square and the root, right? So I'll just have 6 plus 7. Okay, and then here 2 is there, then inside we can multiply. So 6 5s are, we're going to get a 30, or it's going to be 2 root over 30, right? If you're done with that, you can see minus 11 is here, then 6 plus 5 is 11 again. So we can subtract this. Okay, and we'll be left with in the denominator 2 to the power 30. But once again, we still have this root, right? So we have to remove the root. So here even if we take this 2, the answer will still come out. Okay, but here we'll not be taking, we'll just be taking root over 30, right? So in order to remove this, we'll multiply by root 30 and then divide it by root 30 again. So here remember, we're rationalizing 2 times. Clear? So if we're done with that, now next step, this root 6 will multiply with this root 30. So you can see here, then the next root 5 will multiply with root 30. So once again here, and then the next, this root over 11 will multiply with root over 30. So you can already see here, that is what I have written for us there. All right, then the next, if you look at the denominator, 2 is outside, so it will be as it is. Then root over 30 and root over 30 will simply get it to be equal to 30. All right, if we're done with that, now this 6 can be written as 2 into 3, right? And then 30, if you look here, then 5 6 are 30, then 2 3s are. So in place of writing 6 into 30, can I write it 2 into 3 into 2 into 3 into 5? We can write it down, right? So same thing I'm going to do with this 30 here again, right? This is 30 can be written as 5 into 6. This 5 is already there, okay? Then this 30, 5 into 6, okay, right? And the next 11 into 30, because there's no common, we can't do anything, so just multiply them. We're going to get 11 into 30 equals root over 330, right? So now for me, you can see we have pair here 2, 2, and then 3 and 3. So I'm writing it down in terms of square. Same thing here, 5 square is here, right? So we're writing it down here like that. And then let's go to the next step here. So we already know these are pairs here, and even this is a pair, which means they can come out, right? So from the first 2 and 3 will come out, and then from the second, this 5 will come out. Okay, they're coming outside. Now let's multiply 2 3s, we're going to get 6, then 5, and then this is our answer.